In the previous lecture, we have started the Fourier transform. Okay. So, for a continuous time signal, for a continuous time signal xt, the Fourier transform of x of t is equal to, this is minus infinity to infinity, x of t e raised to the power minus j omega t, this is dt. Means by using the Fourier transform, we are transforming the independent variable from time domain to frequency domain. So it will be a function of frequency, that is x omega. So we are just changing the signal from time domain to frequency domain. In the similar way, we can transform this signal from frequency domain to time domain by using the concept of inverse Fourier transform. So inverse Fourier transform of x omega can be written as, this is equal to 1 upon 2 pi, limit is minus infinity to plus infinity, function is now x omega e raised to the power, in Fourier transform we are using the exponential function as e raised to the power minus j omega t, but in case of inverse Fourier transform we will use as plus j omega t, and this is d omega, and it will be denoted by xt. So keep in mind that is the inverse Fourier transform of x omega will be equal to 1 upon 2 pi over integration minus infinity to infinity. Now function is x omega e raised to the power j omega t and d omega, which is denoted by xt. Means by using the application of Fourier transform and inverse Fourier transform, we can change a signal from time domain to frequency domain as well as from frequency domain to time domain. Now in this lecture we will discuss some important properties of Fourier transform. So properties of Fourier transform. So very first property of Fourier transform that is very important, this is linearity property. So according to linearity property, if we have a complex signal, means a signal may be a combination of two or more signals, then individually we can calculate the Fourier transform of these signals, and finally the Fourier transform of composite signal will be equal to sum of the Fourier transform of individual signals. So according to this property, this is linearity property, linearity property which is also called as principle of superposition, means you are superimposing two or more signals. Okay, so according to this property, if we have two signals, that is if Fourier transform of signal x1t is equal to, this is given by minus infinity to plus infinity, this is x1t e raised to the power minus j omega t dt. Suppose this is denoted by x1 as a function of omega. Similarly, the Fourier transform of x2t is equal to, this is minus infinity to infinity, this is x2t e raised to the power minus j omega t dt, and suppose it is denoted by a function x2 as a function of omega. Then if we have a composite signal such that Fourier transform of xt is equal to x1t plus x2t, we are combining these two signals, that is x1t and x2t will be equal to the sum of the Fourier transform of individual signals, that is x1 omega plus x2 omega. Okay, so if you have the combination of two or more signals and you have to find the Fourier transform of composite signal, then simple calculate the Fourier transform of individual signals, then add them, or there may be a subtraction also. So we will prove it. So Fourier transform of x1t we can write as, this is equal to integration minus infinity to infinity, that is x1t e raised to the power minus j omega t dt, which is expressed by x1 as a function of omega. Similarly, Fourier transform of x2t is equal to minus infinity to plus infinity x2t e raised to the power minus j omega t dt is equal to x2 omega. Okay, but we have to find the Fourier transform of what? Composite signal, that is x1t plus x2t. So we can also write that plus minus. Plus minus means either you are adding the signal or you are subtracting the signal. It will be equal to minus infinity to infinity. Now the signal we have, it is x1t plus minus x2t. This is composite signal e raised to the power minus j omega t dt. So we can break this integration from minus infinity to infinity. It is x1t e raised to the power minus j omega t dt plus minus integration minus infinity to plus infinity x2t e raised to the power minus j omega t, and this is dt. See here, this is the formula for Fourier transform of x1t. You can see this from equation of Fourier transform, that is Fourier transform of x1t is equal to integration from minus infinity to plus infinity x1t e raised to the power minus j omega t dt, which is denoted by x1 omega. So we can write it, this is x1 omega. Similarly, this is plus minus, this is the Fourier transform of x2t, so this will be x2 as a function of omega, and this is the Fourier transform of x1t plus minus x2t. Is it clear? Hello? ठीक है, ठीक है बेटा. So this is very first property which is very important to determine the Fourier transform of a composite signal. So in the further lectures we will discuss some important examples based on linearity property. So for the same time we are going just in continuation with all the properties. So second properties we will discuss here. The properties number second is the time shifting property. Time shifting property. Time shifting property. As I have already told you what is the time shifting. So time shifting may be time delay and time advance. Okay, so there may be a time delay signal or time advance signal. So according to this property, if Fourier transform of x of t is equal to, this is x omega, suppose, then if we are making a time shift, Fourier transform of x t minus t naught. So what is t minus t naught? It is time delay, is equal to, it will be e raised to the power minus j omega t naught x omega. Means if we are making a delay in time domain, then an exponential decreasing function will multiply in frequency domain. Similarly, we can write for time advance. Similarly, Fourier transform of x t plus t naught will be equal to e raised to the power j omega t naught x omega. Here we are making time advance in time domain, then an exponential increasing function is multiplied in frequency domain. So let's prove it. Fourier transform of xt is equal to, this is from minus infinity to plus infinity xt e raised to the power minus j omega t dt, which is denoted by x omega. Okay, now we have a new signal xt minus t naught. So we have to determine the Fourier transform of xt minus t naught, which will be equal to, now from minus infinity to plus infinity, it will be xt minus t naught. We will put just xt minus t naught in place of xt, e raised to the power minus j omega t dt. Now we will integrate this signal with respect to time. So let t minus t naught is equal to k. New variable we have select for t minus t naught. So t will be equal to, this is t naught plus k. We have required the differentiation of t, so dt will be equal to, this is t naught is any constant, so differentiation will be 0, plus k is variable, so it will be equal to dk. Now Fourier transform of x t minus t naught will be equal to, now the limit of integration will be changed here, because these limits from minus infinity to infinity are for time t. Now new limit will be for k. So we will put the lower limit as minus infinity. So minus infinity minus t naught will be equal to minus infinity. So here k will be equal to minus infinity. Upper limit we will take plus infinity. So when we will take the plus infinity, it will also infinity, so it is infinity. So there is no change in limits. Now this signal will be x of k e raised to the power minus j omega, and we will take the value of t is equal to t naught plus k, and this is dk. So we are writing one more times it for clarification. K is equal to minus infinity to infinity. This is xk e raised to the power minus j omega. Now t is replaced by t naught plus k, and this is dk. So this will be minus infinity to infinity. This is xk. We will expand this exponential function as e raised to the power minus j omega t naught e raised to the power minus j omega k, and this is dk. Now with respect to k, this function is constant, so we will take it outside the integration. It will be e raised to the power minus j omega t naught integration minus infinity to infinity, because these are the limits of variable k. This is xk e raised to the power minus j omega k, and this is dk. So now we have just changed the variable t with k. So here you can see that there is xk e raised to the power minus j omega k in place of e raised to the power minus j omega t, and this is dk in place of dt. So e raised to the power minus j omega t naught, it is just Fourier transform of xt, that is x omega. So Fourier transform of xt minus t naught is equal to e raised to the power minus j omega t naught x omega. Similarly, we can write for positive or time advance, xt plus t naught is equal to e raised to the power j omega t naught, and this is x omega. So this is the second property, that is important property, in which we are making the time shifting. Okay, so similarly we will deal the next property, that is time scaling. So property number third is time scaling property. Time scaling. What do you mean time by time scaling? In time scaling, either we expand the time or contract the time. So we will see here, if we expand the time, then what will be the effect in frequency domain? Okay, dear student, are you listening me? Hello. ठीक है बेटा. Okay, okay, okay. So now we are expanding the time, and we will see the effect of this time expansion in frequency domain. So let, if Fourier transform of a signal x of t is equal to x omega, now we have to expand this time by a constant a, then Fourier transform of a new signal x at is equal to, it will be 1 upon mod a times of x. Now frequency will be replaced by omega upon a. Okay, So clearly you can see here we are expanding the time. So it is time expansion. It is what? It is time expansion, and here it is frequency contraction. Frequency contraction. Okay. Means if you are expanding the time, you are contracting the frequency. In the same way, if you are contracting the time, you will expand the frequency. So this is very important frequency when you deal with your filters. I have already told you that this chapter is very important from the designing, from the point of view of designing the filters. So let's prove it. Fourier transform of x of t is equal to, it is defined from minus infinity to plus infinity, xt e raised to the power minus j omega t, and this is dt, and we write it by x omega. Okay, now we have to determine the Fourier transform of actually x of at. So Fourier transform of x of at is equal to minus infinity to infinity. This function will be x of at e raised to the power minus j omega t, and this is dt. Now we will replace this at by a new variable. So let at is equal to, this is suppose k. So t will be equal to k by a. Now we require the derivative of time, differential derivative. So dt is equal to, it will be 1 upon k as it is constant, and this is dk. Now we will see the limit. When we will take t is equal to minus infinity, k will be minus infinity. When we are taking t is equal to plus infinity, k will be plus infinity. So there is no change in limit. So Fourier transform of x at is equal to, this is minus infinity to plus infinity. It is a function of new variable, that is xk e raised to the power minus j. Now omega t is replaced by k by a, so it will be k by a, and this is dt is equal to 1 upon a and dk. We can write it again, minus infinity to infinity, this is 1 upon a, it is constant, xk e raised to the power minus j. Now write this expression in this manner, that is omega upon a, and this is k, and this is dk. So 1 upon a is constant with respect to k. So 1 upon a will be outside the integration. Integration minus infinity to plus infinity. This is x of k e raised to the power minus j omega by a, and this is k, and this is dk. Now see here we are seeing that this is the expression for Fourier transform of xk. So here this is xk e raised to the power minus j omega k होना चाहिए था, but we are making a shifting here in omega. The omega new frequency is now not equal to omega. Now it become omega upon a due to the expansion in time. So it will be 1 upon a, it will be a function omega upon a. It will not be a function of omega, it will be a function of omega when only here the term will be omega, but this term is contracting by a factor of a, so new frequency is omega upon a. So this is Fourier transform of x of at. Now because this is the amplitude, this is the magnitude, so we take the magnitude of a, because a may be positive factor or negative factor. So this is the Fourier transform of f x at. So this is the property number 3rd. हेलो बेटा, आप लोगों को समझ में भी आता है कि यार नहीं ऐसे ही बोलते रहते हो? क्यों भाई? हेलो, आ रहा है समझ में? है, थोड़ा 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 आ रहा है। तो भाई आप बताते क्यों नहीं कि कहाँ नहीं समझ में आ रहा है, बताइएगा। भाई थोड़े थोड़े में तो गड़बड़ है ना यार, बताइएगा। अभी मैं आपसे, नहीं, आप ये देखिएगा, जो चीज मैं आप लोगों को समझा रहा हूँ क्या वो चीज समझ में आ रही है, कहीं ऐसा तो नहीं है कि किसी स्टेप में आप कंफ्यूज हो। ठीक है ना, प्रैक्टिस तो आप लोगों को प्रैक्टिस तो करनी पड़ेगी ना आप लोगों को, बिना प्रैक्टिस के तो नहीं आएगा। बट ये ना हो कि मैं कोई स्टेप समझा रहा हूँ वो स्टेप, और मुझे नहीं लगता कि मैं कोई स्टेप आपको समझा रहा हूँ बहुत सिंप्लीफिकेशन वे में, आपको सिंप्लीफाइड वे में बता रहा हूँ। ठीक है ना। चलिएगा, तो सेकंड प्रॉपर्टी है आपकी फ्रीक्वेंसी शिफ्टिंग। प्रॉपर्टी नंबर फोर्थ इज frequency shifting, frequency shifting, frequency shifting। इससे पहले हमने जो प्रॉपर्टी की थी वो क्या थी आपकी, टाइम शिफ्टिंग। मीन्स टाइम में हम शिफ्टिंग कर रहे थे, अब हम किस में शिफ्टिंग कर रहे हैं, फ्रीक्वेंसी में। तो अकॉर्डिंग टू दिस प्रॉपर्टी, इफ Fourier transform of x of t is equal to, this is x omega, then Fourier transform of e raised to the power j omega naught t xt will be equal to x as a function of omega minus omega naught। समझिएगा इसको, देखिएगा, अगर टाइम डोमेन को हम किसी फ्रीक्वेंसी फंक्शन से मल्टीप्लाई कर रहे हैं ई रेस टू द पावर जे ओमेगा नोट टी से, तो यहाँ पर हम क्या कर रहे हैं, मल्टीप्लाई कर रहे हैं, लेकिन फ्रीक्वेंसी डोमेन में क्या होगा, ये हमारे सिग्नल को ओमेगा फ्रीक्वेंसी से कहाँ शिफ्ट कर देगी, ओमेगा माइनस ओमेगा नोट पर। ठीक है ना। अगर हमारा पहला सिग्नल कहाँ मिल रहा था, हमारा पहला सिग्नल यहाँ मिल रहा था, सपोज ओमेगा इज इक्वल टू जीरो पर मिल रहा था कुछ सिग्नल, तो अब ये सिग्नल हमें कहाँ मिलेगा, ओमेगा इज इक्वल टू ओमेगा नोड पर मिलेगा। ये सिग्नल हमें यहाँ मिलेगा। ठीक है ना। इसी तरह से सिमिलरली फोरियर ट्रांसफॉर्म ऑफ ई रेस टू द पावर माइनस जे ओमेगा नोट टी, किसी नेगेटिव एक्सपोनेंशियल फ्रीक्वेंसी फंक्शन से अगर आप मल्टीप्लाई करते हैं एक्स टी को, सो इट विल मेक ए शिफ्टिंग इन फ्रीक्वेंसी एंड इट विल बी ओमेगा प्लस ओमेगा नोट। So positive exponential function multiply by time signal makes the time frequency delay, and negative frequency signal multiply by the time signal gives you time, sorry, frequency advance, that is omega plus omega naught. So prove it. Fourier transform of x of t is equal to minus infinity to plus infinity. This is xt e raised to the power minus j omega t dt. It is written by, this is x omega. Now we have to determine Fourier transform of e raised to the power j omega naught t xt is equal to, it will be minus infinity to plus infinity xt e raised to the power j omega naught t e raised to the power minus j omega t dt. So we can write it, this is from minus infinity to infinity xt e raised to the power minus j, it will be omega minus omega naught into t, and this is dt. So you can see here we have not the frequency omega. Now the new frequency is omega minus omega naught. So this formula is for Fourier transform of xt. So it will be denoted by x omega, but omega is shifting from omega is equal to omega naught. So we can write it, this is x omega minus omega naught. You can direct write it because now it is the function of omega minus omega naught. When here there is a single frequency omega, then you have write it as a function of omega. But now this is a function of omega minus omega naught, so it will be a function of omega minus omega naught. So Fourier transform of e raised to the power j omega naught t xt is equal to this. So this is very important property. This property is very important. Why it is important? Because by using this property we will determine the Fourier transform of a constant DC signal as well as a constant number. Okay. Similarly, we can write Fourier transform of e raised to the power minus j omega naught t xt is equal to, this is x as a function of omega plus omega naught. Okay, so this property is called as the frequency shifting property. बेटा आप लोगों को समझाने के लिए ही मैं सारे प्रूफ करा रहा हूं, अदरवाइज प्रूफ आर नॉट रिक्वायर्ड. ठीक है ना. आप लोगों को मैं वैसे भी सारी प्रॉपर्टी लिस्ट करा देता, आपको समझा देता. ठीक है ना. लेकिन समझाने के लिए ही आप लोगों को प्रूफ करा रहा हूं, जिससे आपको फिजिकल इंटरप्रिटेशन समझ में आ जाए. ठीक है ना. तो नेक्स्ट प्रॉपर्टी देखते हैं. प्रॉपर्टी नंबर 5, डिफरेंशिएशन इन टाइम डोमेन. डिफरेंशिएशन इन टाइम डोमेन. Differentiation in time domain. ठीक है. So according to this property we have to determine the Fourier transform of the derivative of a signal. So Fourier transform of x of t, we know it is equal to x omega. So Fourier transform of dxt upon dt, it is the first derivative, is equal to, it will be omega and x omega. सिंपल. आप लोगों ने लाप्लास की प्रॉपर्टी पढ़ी होगी बेटा. इट विल बी, सॉरी, जे ओमेगा. ठीक है ना. तो वहीं एस को हमने रिप्लेस किया है बाय जे ओमेगा. नाउ इफ वी हैव टू कैलकुलेट Fourier transform of nth derivative, that is dn xt by dtn. So it will be equal to, this is j omega to the power n and x omega. Okay, simple. If you are taking the first derivative, then take it n is equal to 1. If you are taking second derivative, put the value of n is equal to 2. So let's prove it. We have Fourier transform of xt is equal to minus infinity to infinity xt e raised to the power minus j omega t dt. Now we will apply, keep in mind, when we are determining the Fourier transform of derivative, then apply the concept of inverse Fourier transform. So this is equal to what? It is equal to x omega. So we can write inverse Fourier transform of x omega. So it will be equal to xt na. It will be equal to xt is equal to, what is the formula? It is 2 pi 1 upon 2 pi, and frequency is varying from minus infinity to plus infinity. This is x omega e raised to the power j omega t, and this is d omega. This is the formula for inverse Fourier transform. Why we are taking inverse Fourier transform? Because we have to determine the derivative of this xt. So differentiate this xt with respect to time, you will get dxt upon dt is equal to 1 upon 2 pi integration minus infinity to plus infinity. Okay. This is x omega. It is constant with respect to time because you are differentiating with respect to time. So you are differentiating d upon dt of e raised to the power j omega t, and this is d omega. So 1 upon 2 pi integration from minus infinity to infinity, this is x omega. Differentiate with respect to time, you will get e raised to the power j omega t into j omega. This is d omega. So 1 upon 2 pi j omega minus infinity to plus infinity x omega e raised to the power j omega t, and this is d omega. So j omega we are taking outside, it will be 1 upon 2 pi minus infinity to plus infinity x omega e raised to the power j omega t d omega. Now see here, the Fourier transform of xt is equal to 1 upon 2 pi x omega. X omega is the Fourier transform of xt e raised to the power j omega t. This is equation first. This is equation second. If we compare equation first and second, compare equation first and second, you can see this j omega, you can write it j omega and xj omega, except j omega and xj omega all the terms are same, so it will be equal to j omega x j omega. You can also write this j omega with x omega, so it will be the inverse Fourier transform of d j omega x j omega. So this is dxt upon dt to the Fourier ट्रांसफॉर्म. ठीक है बेटा, तो आज के लेक्चर में इतना ही करते हैं क्योंकि टाइम भी आपका होने वाला है. ठीक है, तो नेक्स्ट लेक्चर में वी विल डिस्कस द डिफरेंशिएशन इन फ्रीक्वेंसी डोमेन. बताइएगा, कोई प्रॉब्लम हो तो बताएं मुझसे. हेलो, क्या हुआ? अच्छा अच्छा, 1/2 पाई बेटा, आपको मैंने फॉर्मूला बताया था इनवर्स फोरियर ट्रांसफॉर्म का. जो फॉर्मूला होता है एक्स टी का फोरियर ट्रांसफॉर्म क्या होता है? एक्स ओमेगा. एक्स ओमेगा का इनवर्स क्या होगा? एक्स टी. और एक्स टी का मैंने आपको फॉर्मूला बताया था एट द टाइम ऑफ स्टार्टिंग द लेक्चर. इट इज 1/2 पाई फ्रॉम माइनस इन्फिनिटी टू प्लस इन्फिनिटी एक्स ओमेगा ई रेस टू द पावर जे ओमेगा टी एंड डी ओमेगा. दिस इज द फॉर्मूला फॉर इनवर्स फोरियर ट्रांसफॉर्म. ठीक है ना? चलिएगा, अभी हमारे पास बेटा 5 मिनट और है, एक प्रॉपर्टी और देख लेते हैं. ठीक है ना? तो नेक्स्ट प्रॉपर्टी इज, दिस इज प्रॉपर्टी नंबर 5th ना, दिस इज प्रॉपर्टी नंबर 6. डिफरेंशिएशन इन फ्रीक्वेंसी डोमेन. डिफरेंशिएशन इन फ्रीक्वेंसी डोमेन. फ्रीक्वेंसी डोमेन. अभी तक हम, ये बहुत इंपॉर्टेंट प्रॉपर्टी है, अभी तक हमने जो डिफरेंशिएशन देखा था वो किस में देखा था? टाइम डोमेन में. अब हम डिफरेंशिएशन देखेंगे किस में? फ्रीक्वेंसी डोमेन में. So according to this property, if Fourier transform of xt is equal to x omega, then Fourier transform of, if xt is multiplied by t xt, then the Fourier transform it will be equal to j d x omega upon d omega. Okay, now this time may be multiplied by xt. Suppose it is multiplied by t की power n, it may be t square t cube xt, then the general formula will be equal to j to the power n nth derivative of x omega with respect to omega. Okay, this is the general formula. So prove it. थोड़ा टाइम कम है इसलिए थोड़ा मैं जल्दी बता रहा हूँ आप लोगों को. Fourier transform of xt is equal to, from minus infinity to infinity, this is xt e raised to the power minus j omega t, this is dt, and it is denoted by x omega. Now we have to determine the Fourier transform of what? It is txt. So it will be from minus infinity to plus infinity txt e raised to the power minus j omega t, and this is dt. ठीक है, तो अब देखिएगा यहाँ पर हमें इंटीग्रेशन करना है किसका? टी एक्स टी ई रेस टू द पावर माइनस जे ओमेगा टी. बट वी कैन राइट इट, इट इज एक्स ओमेगा. देखिएगा, इक्वेशन नंबर फर्स्ट, ये इक्वेशन नंबर सेकेंड. फ्रॉम इक्वेशन फर्स्ट, फ्रॉम इक्वेशन फर्स्ट देखिएगा, वी कैन राइट एक्स ओमेगा इज इक्वल टू माइनस इन्फिनिटी टू प्लस इन्फिनिटी एक्स टी ई रेस टू द पावर माइनस जे ओमेगा टी, दिस इज डी टी, ये लिख सकते हैं. वी हैव take the differentiation of x omega with respect to omega is equal to minus infinity to plus infinity. Xt is constant with respect to omega, so xt d upon dt of e raised to the power minus j omega t, sorry, this is d omega and this is dt. So make the differentiation, it will be minus infinity to plus infinity xt e raised to the power minus j omega t, and because we are taking the differentiation with respect to omega, so here it will be minus j t into dt. So take it outside the integration, this is minus jt integration minus infinity to plus infinity xt e raised to the power minus j omega t dt. Okay, this is dx omega upon d omega. Multiply by j both side, so this is j dx omega upon d omega will be equal to j square is minus 1, so इसको क्या लिख सकते हैं हम, माइनस और माइनस कितना हो जाएगा प्लस, माइनस इन्फिनिटी टू प्लस इन्फिनिटी, दिस इज टी एक्स टी e raised to the power minus j omega t, this is dt. Now this is the function, so this is j dx omega upon d omega is what, this is the new function, this is the Fourier transform of t xt. So this is called as the डिफरेंशिएशन इन फ्रीक्वेंसी डोमेन. ठीक है बेटा, तो आज के लेक्चर के लिए इतना ही. आपकी अगर कोई क्वेरी है तो बता दीजिए, नहीं तो आप व्हाट्सअप कर सकते हैं. ओके, थैंक यू.